Okay, so I'm going to talk to you about how to use the molar road to make conversions in between different units for the same substance. Now, we're only dealing with one thing. Like I want to know the mass of water if I know how many molecules of water I've got, or I want to know what volume a certain number of oxygen molecules will occupy. Now, for some of you, this over here is new. We've not had to work with molarity, right? We learned about this in this last chapter. Okay, so we're going to learn how to get between the volume of a solution using molarity. Now, you could do it with the equation. There's another way to do this, but I think our molar road problems really, this is going to be the easiest way. Okay, the basic rule that holds fast every time is absolutely everything you do goes to or from 1 mole, almost. Okay. Everything we do has to go to or from moles. You cannot ever go from particles to mass in one single step. So every step you do has got to take you to or from moles. Now, in the past, those of us who've done this, it's always been 1 mole, and that's true for those 3 roads right here. This one's going to work a little bit different because of how molarity is set up, but it's not unreasonable and we can cope with it. Okay, so again, everything we do goes to or from moles, absolutely every time. Okay, now we've already done the ones that get us directly between mass and moles, right? We've done this one single thing, but we're especially going to look at what does it take to get like from mass to something else down here, completely different. These boxes right here are gates. They're the like constant, the number that you need to get from one thing to another. For particles, the number is always, right, this Avogadro's number, the 6.02 times 10 to the 23rd. For volume of a gas at STP, it's 22.4 liters. Be really careful with this. Notice that both of these are volume. So don't automatically assume that this 24 gets us to and from volume, because sometimes we're looking at a solution. This is only for a gas. Okay, so 22.4 if we're talking about volume of a gas. Okay, we know how to find molar mass at this point. We look that up, and molarity here is almost always in the question. We'll be told the molarity before we try to do this problem, right? Remember molarity, I've got it written as moles over liters here, but we've always put a capital M on it. They mean the same thing. That capital M represents these moles over liters, so we don't have to write quite as much. Okay, so we're just going to dive into how to solve these problems. Okay, if I wanted, scoot that second one down there. Okay, if I wanted to know how many molecules there are in 2.5 grams of water, right? We've solved these problems before. We put the number we've got at the top, so 2.5 grams of water, and we're going to draw a line underneath of it, and we're going to kind of make it long just in case. And we draw a happy face down here to make ourselves feel better about the process. We draw our multiplication bar. Okay, general rule, whatever's here goes here, and whatever's here is going to go here, and whatever's here goes here every time. The other way to look at it is the bottom, like you would write out a Christmas card. You always write 2 up here above, and then from on the bottom, right? You'd write to so-and-so from me. So this is where we're going to try to go to. This is where we're going to come from. In this step, I want to go from mass to my molar road. Okay. So I'm going to go 2 moles, and I'm going to come from grams of water. Write this every time. I know it's annoying. Do it anyway. Okay. For mass here, I have 1 mole, and I would look up and add from my periodic table, right, the molar mass of water, which happens to be approximately 18.01. That's why I chose water, because I know it. Okay, but we're not there yet, right? I have moles, but I've been asked for molecules. Molecules and moles are not the same thing. Okay, now I've gone from here to here. So now what am I going to do next? Well, I'm going to go 2 particles from molar road. Now, particles is never a unit you'll use. Particles will either be formula units, molecules, or atoms, depending on the substance that we're working with, right? I'm working with water. Water is a covalent substance. It comes in molecules. Okay, so I'm going to go 2 molecules of water from moles of water. So I'm going, whatever's here goes here. Okay? Still 1, 6.02 times 10 to the 23rd. Okay, and we're going to get out our calculators. Okay. And I'm going to push 2.5 okay, times 1, which I'm not putting in, divided by 18.01 okay, times 6.02, and I'm going to push this EE button, 23 equals, okay, and my answer there, if I can get the glare off of it, is 8.3. Yeah, we'll run this to significant figures. So 8.4 times 10 to the 22nd molecules of water. I got close to the edge of that page there, didn't I? Okay. If you're watching your significant figures, you're only watching this number. Okay. Assume you should have added enough decimals in here to make it so that this has more than that up there. Just pretend this is exact. It's not, but pretend it is. And these ones are absolutely exact. Okay, so let's look again at another one. Specifically this time I want to look at what to do with molarity. Okay, so if I have 125 milliliters of 0.8 molar HCl and I want to go to volume of gas dissolved. Okay, I'm starting with this volume of a solution, but remember that our volumes needed to be in liters. So that's the first thing I need to do is rewrite this as 0.125 liters HCl. Okay, so that's going to be my starting number, 0.125 liters HCl. Okay, all right, my gate, my conversion factor this time is going to be the molarity itself. Like I said, I'm going to give you that, but this is written a little bit different. This instead is 0.8 moles over 1 liter. So every other time my 1 has gone with the moles, molarity works just a little bit different. So I'm going to put the 1 with the volume, with the liters. So I'm going to write 1 liter HCl here, 0.8 mole HCl. Okay, well that gets us from our volume to our moles, and now I want to go from our moles to volume of the gas. Okay, so moles go here, moles go here. It's 1 this time. The only time it's not a 1 is when you're working with the molarity, and the molarity is simply going to be in the question. You never have to figure that out for yourself. Okay, so we have 1 mole HCl equals 22.4 liters, the gas, HCl, okay? And then once again, clear that out, we go 0.125 times 0.8 times that 22.4 oh, I suppose that makes sense, okay, equals 2.24 liters HCl. Okay, and that's all there is to it.